Welcome dear all on the numerical session on the belt drives. So we will see our first numerical over here on the belt drives. So simultaneously we are going to collect the given data because uh, while solving a question the most important thing is analysis of the question, what is the given data and what we have to find, and depending upon that what formulas we will require in our solution. So a shaft is rotating at 90 rpm drives another shaft at 225 rpm. So 90 rpm here you can observe 90 rpm is the speed of driving shaft, whereas 225 rpm is speed of driven shaft. So N1 and here 225 is N2 and transmits 10.5 kilowatt. So 10.5 kilowatt is the unit of power. So power is given as 10.5 kilowatt through a belt. The belt is 115 mm wide, so 115 mm is the width of the belt, that is B is given, and 12 mm thick. So thickness small t is also given. The coefficient of friction between the belt and the pulley is 0.25, so mu is also given. The distance between the shaft is 2.75. So distance between shaft, that is x, is also given here, that is 2.75. The smaller pulley is 600 mm in diameter, so diameter of the smaller pulley is also given here, that is it is 600 mm in diameter. Calculate the stress in the belt. So we have to find the stress, also find length of the belt. One thing you should observe over here is in the entire question nowhere it is mentioned that which type of belt drive it is. So whenever in the question it is not mentioned that which type of belt drive it is, by default it is open belt drive. So the stress we have to calculate is for open belt drive, as well as length of the belt we have to calculate for the open belt drive, because stress is dependent on the force, that is tension in the belt, and in open belt drive and cross belt drive we will get different tensions in the belt drive. For all given all the data is same, still we will get different stress in open belt drive and cross belt drive. So whenever it is not mentioned that which type of belt drive it is, always consider it is open belt drive. Now the same data we had analyzed over here, N1 N2, the power. So power is given in kilowatt, we have to convert it in terms of watts, so it is 10.5 into 10 raised to 3 watts. Width small b, thickness small t. So again the width is given 115 mm, so we have to convert it into meters, so it is 0.115 meters. We have to multiply it into 10 raised to minus 3, so we will get finally width is 0.115 meters, whereas thickness 12 mm, so multiplied with 10 raised to minus 3 we will get thickness as 0.012 meters. Coefficient of friction mu, and x, that is distance between shaft, 2.75 meters. Now the diameter of smaller shaft, so diameter of smaller pulley, so you need to observe here which diameter is lesser, whether it is a D1 is given or D2 is given. So you can observe that driving pulley is rotating at 90 rpm and driven pulley is rotating at 225 rpm. That means it is running at a smaller speed and it drives the other pulley at higher speed. So it is, as it is running at a higher speed, that indicates that it is a pulley with lesser diameter. So the pulley with lesser diameter or the least diameter pulley is 600 mm, that's why it is D2 instead of taking as D1. So we have to find R2 based on D2, so it is half of D2, that is 0.3 meters, and we have to find sigma, that is stress. So whenever stress is asked, mostly it is expected that you have to find maximum stress in the belt. Now what is maximum stress we will see later on. So for open belt drive, as we have discussed right now, again we have to find length of the belt, it is also for open belt drive. So this is the simple analysis of question. Basically what you have to find is stress, and second thing you have to find is length of the belt. So let's see how we are going to solve the question and what formulas are available to us for solving these questions and what steps we are going to follow for the solution. So you can observe here, for open belt drive, stress is force per unit cross sectional area. And now as sigma is maximum, so we need maximum force, and maximum force in the belt is tension on the tight side, that is T1, cross sectional area of the belt. So width and thickness both are given, only thing we have to find is T1. Now to find T1, we don't have separate formula to find either tension on the tight side or tension on the slack side. We don't have a separate formula, but instead of that we have two different formulas. One is the formula for power. So in the formula of power, power is equal to T1 minus T2 into V, and the other formula is T1 upon T2 is equal to e raised to mu theta, that is limiting tension ratio. So from by using this formula we have to find T1 and T2 here and T1 and T2 over here in both the equations, and both we will find in terms of T1 and T2, and we will solve two simultaneous equations to finally find the tension in the belt or tight side. So you can observe here, in power equation, that is P is equal to T1 minus T2 into V, power is given, T1 and T2 both are unknown, whereas velocity of the belt small v is also unknown. So small v we can easily find. Velocity of the belt is given by pi dn upon 60. So velocity of the belt pi dn upon 60, either you can take d2 n2 or d1 n1, pi d1 n1 upon 60, or you can take it as pi d2 n2 upon 60, because belt run at a constant speed whether it is over the driving pulley or the driven pulley. Then in this equation, what are the unknowns? So T1 and T2 both are unknowns. Here again T1 and T2 both are unknowns, so we are going to find in terms of two unknowns. This equation in terms of two unknowns and this equation in terms of two unknowns. So two equations, two unknowns we can easily solve as a simultaneous equation. So mu is coefficient of friction, it is given as 0.25. Only unknown over here is theta. So how to find theta? Theta is angle of flap. So how to find theta? And this, you should remember that this theta is in terms of radius because it is out of trigonometric function. So how to find theta? We have the formula for theta. Theta is equal to 180 minus 2 alpha. Remember, what is this minus for? It is for open belt drive only. For cross belt drive it is 180 plus 2 alpha. So for open belt drive it is 180 minus 2 alpha. So here it is minus 2 alpha. Again in this equation alpha is unknown, so we need to find alpha. So alpha in open belt drive is given as sine inverse of under bracket r1 minus r2 divided by x. So sine inverse of r1 minus r2. So in case of open belt drive it is r1 minus r2, whereas in case of cross belt drive it is r1 plus r2. I am telling this for comparison purpose, that for open belt drive what you will take and for cross belt drive what you will take. So it is r1 minus r2 divided by x. So again here r1 is also unknown, d2 is given. So n2 upon n1, n2 and n1 both are given. d1 n2 upon n1 is equal to d1 upon d2, that is speed ratio. So d1 upon d2 we can rewrite it as r1 upon r2. So n2 and n1 both are given and d2 is given, that means r2 is also given. So we can easily find by using this equation, that is n2 upon n1 is equal to r1 upon r2. So we can easily find r1. So in this way we have to proceed like this. First we have to find r1 here. First we have to find r1 by using this equation. Then we need to find alpha using this equation. Once we find alpha, you need to put alpha in this equation. Alpha is equal to 180 minus 2 alpha. So once you find alpha, you will get theta, and you have to put theta in this equation. So you will get ratio of T1 upon T2, and you will get a constant over here. So you will find T1 in terms of T2. You can put that T1 in terms of T2 in the equation of power. So before proceeding for the equation of power, we will find velocity of the belt, that is pi pi d1 n1 upon 60 or pi d2 n2 upon 60. You will get velocity of the belt, and you will put t1 in terms of t2 from this equation into this equation. Power is also given. So finally what you will get here is value of t2 by solving these two equations, and once you solve you will get t2, you can easily find t1. So in this way we are going to find t1, and simultaneously we are going to find maximum stress in the belt. So again one more thing has been asked in the question, that is length of the open belt. So pi r1 plus r2 plus 2x under bracket r1 minus r2 bracket square divided by x. Again here r1 is unknown, r2 is given. So r1 we can find, we had already found from here, that is n2 upon n1 is equal to r1 upon r2. The same value of r1 we are going to put over here, and you will, by using the single equation, you can easily find length of the belt. So this is how will the procedure we are going to follow for the solution of this question. So we'll see it now step by step. So first thing is alpha sine inverse of mod of r1 minus r2 divided by x. So instead of taking bracket, if you take is mod of r1 upon r2 divide r1 minus r2 divided by x, it will be easier for you, because under the sine function you should not take a minus sign. So you can better you take it as mod. So sine inverse of r1 minus r2 divided by x, put all the values 0.75. So r1 we will get from the equation is 0.75, n2 upon n1 is equal to r1 upon r2. From that equation we can find r1 as 0.75 minus 0.3 divided by 2.75, and finally you will get alpha. Alpha is 9.41 in terms of degrees only, you should remember it. It is in degrees. So once you find alpha, you can easily find theta. Theta is equal to 180 minus 2 alpha. So 180 minus 2 alpha, as alpha is in degrees, so theta you will get in degrees. So to convert it into radians, you have to multiply it with pi by 180. Once you will multiply whatever is the value by pi by 180, it will get converted into radians. So finally what you will get is solution of this part, 180 minus 2 alpha, you will get 161.61 into pi by 180. So we will get theta in terms of radians as 2.812 radians. Now we can also find velocity of the belt, pi d1 n1 upon 60 or pi d2 n2 upon 60. Putting all the values, pi d1 and pi d2 n2 upon 60 or pi d1 n1 upon 60, you will get same values. So we will get velocity of the belt as 7.068 meters per second. Then limiting tension ratio in the belt. We are following the same steps we are discussed earlier. So T1 upon T2 is equal to e raised to mu theta, in which left hand side is completely unknown and right hand side e raised to mu is 0.25, and theta we had just found out in the previous slide. So put all the values, what you will get is T1 upon T2 is equal to 2.0198. So multiply T2 from here to here, what you will get is T1 is equal to 2.198 into T2. Name it as equation number 1. So first thing you have found is T1 in terms of T2. Now power transmitted. So one equation we had found T1 in terms of T2. Now we are going to find T1 in terms of T2 by using second equation. So first thing, write the power equation. Power is equal to T1 minus T2 into V. Velocity we had already found, power is already given. So put power here, velocity over here, and from equation 1 write T1 as 2.0198 into T2 over here. So in the entire equation we have only single unknown, that is T2. By substitution, so we can find T2 as 1456.6 newtons. Once we had found T2, so put in equation number 1, you will get T1. So T1 will get is 2942 newtons. Remember, the unit of tension is in newtons in both the cases, and you can compare from here that T1 is always greater than T2. T1 is always greater than T2, that is tension on the tight side is greater than tension on the slack side. So T1 and T2 we had found both. Yet our question is not complete because we have to find stress in the belt on the tight side. That is the maximum stress. So maximum stress sigma max is equal to T1 upon area, that is force upon area, and the maximum force is tension on the tight side. So 2942 divided by area is B into T. So width is 0.115, it is given in the question, and thickness also given 0.012 meters. Put all the values here on the denominator in terms of meter only. So all units are in SI units. So maximum stress you will get 2.131 into 10 raised to 6 Newton per meter square. So remember the unit of the stress, Newton per meter square. You can also write it as pascals. So sigma maximum is 2.131 into 10 raised to 6 pascals or 2.131 megapascals. Now one last thing is remaining is length of the belt, which is also asked in the question. So length of the open belt drive, it is given by the formula length of the open belt drive pi under bracket R1 plus R2 plus 2x plus under bracket R1 minus R2 bracket square divided by x. All the values we had already found. We have to substitute all the values and we can easily find length of the open belt. Substitute all the values. We are substituted over here. So finally we'll get length of the open belt, that is 8.87 meters. So two things have been asked in the question, that is length of the open belt and maximum stress in the belt. Both things we had found. Now in the next question we will use the same data of the question number 1, so that we can easily compare how to solve question number 1 and how to solve the same question for open belt drive and cross belt drive. So comparison will be easy. So I am using the same data for cross belt drive also. Thank you for this session. We will continue in the next session with the cross belt question on the cross belt drive. Thank you.